Guys, Fru here. Welcome to today's lecture. So in today's lecture, we are going to be diving into numbers. So today we are going to look at lecture 102 within module 1, Python basics. And specifically, we're going to be working with numbers. In the previous lectures, we saw variables, we saw introduction. So today we're going to look at numbers within Python. If we dive into that particular lecture, the content for that, there's a lot of concepts we want to cover within this particular lecture. So everything from understanding basic numbers, number types, what does it mean for numbers to have different types. We're going to look at some basic arithmetic operations with numbers, order of operations, kind of like bookmarks in grade school mathematics. We're going to look at some functions to work with numbers within Python. We're going to see how to convert numbers from one type to another type. And then at the very end, we're going to see how to print random numbers. So sometimes it might be important for you to just randomly generate a number to use it for something else. So we're going to see some of that. And after we go through this lecture, once we cover all of this, it might be possible for you to go out. As a matter of fact, by that time, you should be able to go out and to write your own calculator. For example, you can write a program that takes two numbers and do additions on them, right? Or you can write your own a multiplication table. All right, you can have take any number and find the square root. So if it comes to working with numbers right after this lecture, you should be able to be very versed with working with numbers within Python. So guys, this will be a very exciting lecture. I'm very excited as always. Just bear with me. As always, all the code is going to be available for us within my GitHub here. So if you want to get access to the direct code, just check out my GitHub link, get access to it. That way you can follow along. But I highly encourage you to follow along first, and then to only use what I provide within my GitHub as a supplementary to supplement your knowledge on the concepts. All right. So if something is off somewhere, you can use what I provide within GitHub under the numbers file, lecture 102 numbers file to be able to follow along. So all right. So we're gonna dive in as always. Let's switch over into my PyCharm. We already set up PyCharm a couple of lectures ago. So usually what I like to do is just to come in here from the very beginning. I'll do a pull. So this is going to go back to GitHub because sometimes I make changes in GitHub. I want to bring them to this environment so we have something to work with. The lecture file, once you pull it, will be numbers.py. So that has all my code, but I'm not going to be running the code here. I'll instead go to the working area in the canvas, so we can start writing the code from scratch. Let me pull this to the side, make it smaller, so we have more space to write our code. All right, so numbers. This is the first thing that they teach in school, right? Kids, how to count from 1, 2, 3, 4, 5, all right? Those are your integers. Integers, right? And then after a while, they start teaching you fractions, all right? Or decimals. And then well, you have integers, you have natural numbers, and then all of a sudden you have sign numbers, right? Negative numbers. So the number line goes on the other side. All right, let me actually bring this up and search for the number line. I think that might be easier. All right, so let's find the number line. That's the very first link I see. I'm gonna click on that. All right, well, this is a very basic number line. Let's actually look at this one. All right, so you have your positive numbers, you have your negative numbers, then in between you have fractions, which could be decimals, right? Those are all numbers. And then once you start taking more advanced courses, right, or make it maybe to a college level, you might start hearing about complex numbers, right, and abstract numbers, and it just kind of goes on and on. So there are many types of numbers out there, but the goal for this is to say whether we have a positive number, a negative number, a decimal, a fraction, can we take those numbers and do all the mathematical operations that we need to do within, like addition, subtraction, division, multiplication, square root, and whatever we want to do with numbers. All right, that's really going to be the focus of this. So there are lots of concepts within numbers. So we're going to dive into the very first one here that we're going to look at, and this would be let me make sure that I get the right one. 1.2.0. all right, and this would be basic numbers in math. All right, so let's say, think of a number, right? Some random number 3, right? In Python, we can come ahead to the screen and we can say print Just type your number in there, 3, on the screen, and Python would print that for us on the screen. By now we should be familiar with printing things on the screen. We saw how we were able to print strings on the screen. Now we're seeing how we can just take numbers, any number you can think about, right? Take I'm just putting any number in there, and we can print that on the screen. All right, so that's the number printed on the screen. Very basic, very basic. Now what about so this is an integer. All right, let's say this is an integer. An integer is just a positive or whole number, depending on how they define that in kindergarten or in grade school. I don't quite remember that very well. An integer is a whole number, right? And then this one is, what is that? 3.1147, whatever that is. So this is not an integer anymore, right? So we can print an integer. This one is decimal, right? Or sometimes called a double or float, right? You'll start hearing about some of these concepts a little bit later. All right, so we can also print decimals on the screen, no problem. In Python, it can take a decimal and it can print that on the screen. But not only decimals, right? We can go ahead, let me copy this. We can print -5, all right? So we can also print signed numbers, all right? So we've basically gone across the number line, right? We've seen our positive numbers, positive integers, all right? We've seen fractions, right? We've seen signed numbers, all right? And we can print all of that on the screen in Python. Let me run this. We can print all of that on the screen in Python without any problem. So we can see me being able to print all of this on the screen, absolutely no problem. All right, now guys, is this gonna be a very exciting video if all we do is just to take random numbers and print on the screen? I don't think so. So that's why we're gonna have to dive into the next concept, which would show us build on this concept of all the numbers that we have within Python. And this one will be 1.2.1, and the focus of this particular concept is to talk about more number types, right? Number types, and which we've seen int, it's a little bit slow typing, decimals, or let's call it floats, and complex. All right, so that's what we're gonna see here. So now complex numbers. All right, so let's take this one step further. So in the previous lecture, in the previous concept, we saw how we can just print numbers on the screen. I'm gonna comment this out so that we can start from afresh here. All right, so now what we're gonna do here is we're gonna set some numbers. So we can say x equals 5. All right, the way we were able to set strings within for strings as variables in the previous lecture. If you check on that lecture, somewhere here or here, I'm not sure where that might show, you would see us being able to set strings, and we can do the same with numbers. All right, so I can go ahead and I say print x, all right, and guess what, just skip that. I don't want to commit that to Git. I want to run it instead. All right, and it's gonna print 5, right? And you might say, why x? It doesn't have to be x. I can say ish, my ish equals, of course it's not 5, right? For those of you out there not 5 years old. All right, my ish print my age, right? So you can set any variable to a number. You can set any variable to a number. Now we can take this even further, right? We can say, let me just stick with x and y, just so, because in math sometimes you see a lot of x, y, and z and j and all of that. So let's say y equals 7.8, z equals, let's actually stick with y first. All right, let's say print y. All right, so it's gonna print 7.8 for us. Now let's try something else. Let's say z equals to 3j. All right, let's go ahead and print z. If I go ahead and run that, all right, what does it do? It prints 3J. All right, let's try 3P. All right, if I go ahead and run that, what do you think is gonna happen? Voo. All right, and voo means boo because it did not print. All right, so you're asking yourself, I took a number and I added P to it, it doesn't print. If I add J to it, it doesn't complain and it prints 3J, but why doesn't it print 3P? All right, so 3J prints, 3P prints. Let's look at one other one, 3I. All right, it doesn't print. So what is unique about J? Let's do 3A. 3A still doesn't print, but for some reason, let's say 5J or 5J. So what is unique about J that makes it print? But if you take any other number and you attach a letter to it, it doesn't print. But if that specific letter is J, it prints. All right, that's because there are different types of numbers in mathematics, and that's just simply represented in Python. Now, if this concept doesn't mean anything to you, it's okay. All right, not everybody is familiar with all kind of numbers. So this one we call them integers or whole numbers, right, which we're very familiar with. These ones are called floats, right, or decimals. All right, decimals. And this one is called complex numbers. And this is it's a concept in math, complex numbers, right, where you take your real part and your complex part, and then you have a complex number. If you're not familiar with complex numbers, just go on complex numbers. Just go on Google, on YouTube. You can just read a little bit more about complex numbers. If I do an image here, just to show you a complex number. So a complex number usually is a combination of they call it the real part, and then they call it the imaginary part. And that real part is simply, you know, a, and then the imaginary part is something plus a digit plus some letter behind it, right? So that's complex numbers. That's all I can talk about for complex numbers for now. But if you're curious, just search for complex numbers in mathematics and you can read a lot more about them. That's the kind of concept that's been translated here into Python. All right. So if I do print Z, as long as this is a J, that's fine. There's no problem to it. All right. So that's taking us into the concept of what we call complex numbers. Let me actually modify number types and how to check them, because part of this lecture, part of this concept within this lecture is to also check the number types. And if you're saying, but Fru, you're just telling me this, like, how do I know? How can I just see something on the screen and know what the data type is, right? How do I just know that this is an integer, or just know what this is, or know what this is if I see any new number? All right. You can check that within Python. And the way you check it is, say you have a variable x, we can print x on the screen, right? So it's going to print 30 for us on the screen. But if you want to go ahead and check the type of that number, there is a function within Python that we can use. We can say type, and then x, we wrap that type around that. So what we're saying is print, and then the type, right? So we're wrapping this around this function. Right, let me zoom in again more. I think that's the most I can zoom. So print type x, right? So instead of printing x, so what this is gonna do is gonna print the type of x. So it's gonna tell us what x is. All right, and you can see here it says x is of type int, which means integer. So if there's a number that, or something that you're really not sure what it is, and you want to know what the data type is, that's what type means. They call it data type. You can just simply say print type of that number and you can say it. All right. And the next one we can do here, of instead of doing x, we can do print type of y and z, right? And you'll notice now that y and z. All right. So let me bring this back. So we have three numbers here on the screen. X equals 30, y equals 7.8, and z equals 5j. And we've said these are all different types, and this is what I wrote here. But if you want to verify that, you can actually say print type of X, print type of Y, print type of C. And you can try it with any number you can think about. Write any number on the screen, decimal, negative number, whatever it is, and print the type. And if we go ahead and run this, we're going to see the type of this number. All right. So if I scroll down here, you see that the very first one, this one, 30 is an int. This one is a float. And this is a complex number. All right. Let's change this. Let me put a negative there. All right. If I run this, it's still an integer, even though it's a negative number. So integer is not just positive numbers, right? You have positives and you have negatives too as well. So it accounts for that, right? Floats are just anything that has a decimal to it. And you know, a decimal is just a representation of a fraction, right? And then you have your complex numbers as well. So these are some of the number types that we have within numbers in Python. And these are the ways that you can go ahead and you can check what type of number it is you're working with if you're really curious. All right, now this takes us into the next segment of a concept that we're going to cover, and this will be concept 1.2.3, right? So now in this particular concept, we're going to be looking at mathematical operations with numbers. All right, so this next concept now is going to be taking us, instead of just looking at numbers and printing numbers and checking the types of numbers, can we actually take numbers within Python and do mathematical operations with those numbers? That's what we're going to be looking at here. And maybe I got that wrong. One, okay, so that's two. That should be two. Bear with me, guys. So that's concept number 1.2.2, and if you're checking into my Git repo, all right, so concept the 1.2.2. If you're wondering how I'm naming this, basically 1 is still module 1. All along we've been on module 1. 2, this is lecture 2, and the 2, this is the concept 2. So you have a module, the lecture, and then within that lecture we have the concept. So if I go back one more, module 1, so this is module 1, which is Python basics. If you notice, there are many modules that we have coming up. All right, there are many modules, Python operations and data types and structures. So we're still on module 1, so this is still the basics. And then within that, we're looking at lecture 2. So this is lecture 2. So this is saying module 1, lecture 2. That's what this 2 stands for. And then within that, then we're going 1, 2, and then within the lecture 2, there are many concepts that we're covering, right? Starting from 0, 1, 2, 3, 4, 5. So we're covering a lot of concepts. And right now we're looking at concept module 1, lecture 2, concept number 3, right? And you're saying, but 3? In Python, you start counting from 0. So if you're not familiar with that, I'll talk about that in a different video. All right, so let's go back into Studio, into our development canvas. I call this Studio, but let's look at our development canvas. All right, so mathematical operations within Python. So I'm gonna have to comment out. Just bear with me to do something. All right, so we can go ahead. What I just did there is being able to comment out the block of code, which you can do in Python, and I showed this in the previous video. So if I run this, nothing should happen, because the code has been commented out. All right, so let's look at the next concept here, which would be mathematical operations in Python. So if you have two numbers, can we take two numbers and add those numbers within Python? Sure, we can. So let's say print, right? We take 3. We can just simply use a plus sign, +5, all right? And we can print that on the screen. So if you think about your mathematical operations, any mathematical operation that you might want to do in math, you can do it, right? I can say 3 multiplication, right? That should give us 15. All right, so that gives us 15. So if you think about your addition, subtraction, multiplication, all right, all of that, you can perform that within Python. So 3 minus 5, that gives us -2. All right, so all the mathematical operations that we can perform within Python. As a matter of fact, let me do a couple here. All right, so we can say 3 plus 1.25. Actually, let me not do that. Let me do 1.25. All right, we can do this. So think about Python could literally be a calculator, right? You can want to calculate something, pull up Python and simply just do this, and it can simply become a small calculator for you instead of using your phone or something else. All right, so very, very, very powerful. And we don't have to do just integers or floats the way we've seen here. We can also do, say, print 5 divided by 2. All right, we can also print that and see the value. 5 divided by 2 is 2.5. We can do more. I like to show multiplications. 3 times 3 point that. All right, so that should give us 9 point something. All right, 9.72. all right, so we can do our multiplications. Now we can also do modulus. If you know modular multiplication in modulus in mathematics, you can say print let's do 3. Well, I'll show the modulus later. Let me show something. So 3, let's try this. All right, 1. So basically what this is saying is here is division. So 5 divided by 2, it was 2.5. all right, but this one is simply saying how many 3 divided by 2, what's the remainder. This is like modulo operator, right? In math, when you do a division, you take the remainder, that's your modulus. So if I did 11 mod 2, that will be 1, right? Because 2 can divide 10 and then 1 will remain. So all right, but if I did let's see, mod 3, then that should give us 2, all right, for our modulus. So that's basically a modulus operator. In mathematics, you can also do that within Python. So that's some of the basic calculations that we can do. There's a lot more of calculations that you can do in Python, all right, but this just gives us a basic. Literally take any 2 numbers and you can just use your basic math in Python, and you can write out those numbers. Now what we're going to do here is we're going to take this a little bit further, and the concept we're going to talk about here will be concept 1.2.3. so finally get to 1.2.3, bookmarks, order of operations. All right, so what we do here, let me comment this out, and I'll comment that out. All right, so we're going to look at bookmarks and the order of operations within mathematics. In math, there are certain rules that you have to follow when you're working with numbers and doing some transformations within numbers. All right, so let's say we wanted to work on this number and say print let's do 3 times 2 plus 5. Guys, take a second. What would this calculation return for us? All right, 3 times 2 plus 5. All right, if you've done basic math in grade school or in primary school or secondary school, wherever you're watching, we should be able to perform this operation. All right, so if I go ahead and run this, all right, this prints out 11. 3 times 2 plus 5. And how did it come up to 11, right? If you say, well, did it say 3 times 2? What's 3 times 2? 6. 6 plus 5, what's that? 11. So that's how we got 11. All right, so let's write 11. Now I'm gonna show something again, very, very similar. So I'm gonna say print I'll do 3 times 2 plus 5. So I'm doing the same thing, 3 times 2 plus 5. But instead of just running this piece, I'm gonna introduce something different. I'm gonna put this in a bracket, right? And I'm gonna close this in a bracket. So basically, I've put this piece in a bracket, and then the same values, the same numbers are all on the screen, right? I'm still working with the same numbers here. I haven't changed the numbers, right? We have 3, we have 2, we have 5. We have times and we have plus. Same here, we have 3, we have 2, we have 5. We have multiplication and then we have addition. Same thing, all right? But if I run this, guess what will happen? Intuitively, you might think that the result should be the same, right? But the results would be different, all right? So here, in this first case, I'm getting 11. In the second case, I'm getting 21, all right? Even though I'm working with the same digits and the same operations, but because of bookmarks, if you're not familiar with bookmarks, I highly encourage you to check that out. Bracket of division, multiplication, addition, and subtraction, which says, and this is the order of operations, it says if you see a bracket, so if something is in a bracket, you want to perform that chunk first before you can perform anything else, right? So in this case, what it's going to do, it's going to take 3, it's going to take 2 plus 5, that gives us 7, and then it's going to take 7 times 3, which is 21, all right? Whereas this just follows it sequentially. You can actually control your order of operations by using the bracket, and that's basically bookmarks. It's true in mathematics, it's true here, right? So again, all the mathematical operations that you can think about writing on a piece of paper and performing, you can leverage Python and be able to do it here as such. So very, very important to master this particular concept. Now, this takes us into the next, let me comment this out, to the next concept within the lecture here, and we're going to be looking at 1.2.4, and this will talk about more math functions in Python, all right? So we're going to look at more math functions in Python. If I just scroll back up to 1.2.0, we saw how to print numbers. 1.2.1, we saw the different number types, right, and how to access and print those number types. And then we saw basic operations, right, like minus, division, square, multiplications, modular operations. But we know those are not the only operations that are available in math, right? There are way more operations in math. What about square root, right? What about changing the sign? If I wanted to take a positive number and convert it to a negative number, how can I do all of that within Python? All right, so that's what we're going to be looking at here within this particular concept, because Python offers a whole library, a whole list of ways, of methods that or functions that you can use to work with numbers even more. All right, and we're going to be going through some of those. So in order to do that, I'm going to use a variable here. So I'm going to say my let's just set a variable to a number and say my age equals 30. All right, so that's my age equals 30. Very basic number. So we can go ahead and we can print my age. We should know how to do this by now in our sleep, all right? Because Python, very straightforward for us to do that. So my age equals 30. And we can go ahead and we can print my age. We should know how to do that. Now, what if I wanted to do something different? What if somebody wrote a mistake and they said minus 30, my age equals minus 30? Bear with me, that doesn't make sense. Somebody cannot be minus years old. But we want our Python program, if it sees that, to correct for that mistake and to print only the positive numbers, right? So the way we can do that is we can say print instead of and then we can say my age, but we need to do something to this my age. There's a function called absolute. All right, so we use absolute my age. So what absolute? And it's same as absolute in mathematics. So absolute in mathematics, let me just search that really quick. All right, so absolute value describes, this is a little bit of a complex definition. So absolute value describes the distance of a number on the number line from 0 without considering the direction from 0. Absolute value of a number is never negative. So basically, what this is saying, I'll take that from mathematical terms into English, is that take the number and convert it to positive. If it's minus 5, it's 5. If it's 5, it's 5. So whatever it is, look at it as a positive number, right? So In this case, my age is minus 30. I can now take that. If I do the absolute, so it's just ABS, right? And then you wrap that in my age. And if I print that, it's gonna, here it's gonna print minus 30, but now here it's gonna convert that into the positive number. So if you had any number, so here is minus here, but this second one is positive. So if you had any number, you wanted to get the absolute for it, all right, you can simply just take that, wrap it around the absolute function, and that would convert the number to positive. So this is an example of some of the functions that Python makes available for us to start being able to work with numbers, right? Because if I go back in here, everything I was doing here, like minus, is on your keyboard, division is on your keyboard, multiplication is on the keyboard, modulus is on the keyboard, but there is no key on the board, on my keyboard, that says this should be an absolute, right? But you don't have to worry, because Python provides that function for us, and we can simply call that function for this to change the sign of a value. So think about this as just simply changing the sign of a value to a positive number, all right? And there's way more. We can go ahead and we can say print, all right? And we can take there are more functions, right? We can say there's a function called power, and we can take two numbers, right? We can say 5, 2. All right, let's say you wanted to take a number and raise to the power of something else, right? So say take 5 to the power of 2, right? We know what this should give us, right? 5 to the power of 2 is simply 5 squared, and that should be 25. All right, and that gives us 25. You can literally raise any number to any power, right? I can say that raised to the power of this is that would be a very big number, but Python is gonna do it for us. Wow, that's actually a bigger number than I was imagining. You can see. All right, imagine trying to do this with your calculator, all right, or something that you have on very small calculator. Yeah, it will never give this to you, all right? And that's where Python really starts becoming powerful for scientific calculations now, because I can work with crazy numbers like this, all right? The old I don't have it around here, but the old Casio calculator, or Texas Instrument calculators that you used to have in college, or depending on where you're studying this, would never give you this kind of numbers. But now, because of Python, we can actually get this kind of numbers, work with crazy numbers, right? We can really go ahead and work with all kind of crazy numbers, right? Whereas calculators will never. Let me actually go as crazy as I can here, see if there is a limit. See, it's taking a while for this to run, all right? Because this is this might end up crashing my system, because this is a crazy calculation, all right? I don't even think anybody can realistically figure out this number. But if you really wanted to calculate this kind of thing, you can leverage something like Python and be able to work with those crazy numbers. I'm just gonna stop this so it doesn't maybe crash my system. My memory on my machine is small, but if you had a big machine, and this is what some of the data scientists and computational mathematics people are doing, they're literally being able to take Python, leverage all these mathematical functions, and they do all kind of calculations with it. So if you've ever been wondering, but why Python? Why don't I just use my calculator? Why do I have to worry about Python? Because now with a tool like this, you can start doing all these kind of calculations that will never ever be possible on my tiny calculator here, all right? So Python can just run and crunch at this, and then it will come back with the results to you. You're right, you might need a bigger CPU, you might need like a GPU, and some of these very fast supercomputers, but again, this is what data scientists, machine learning experts, people with AI are kind of using Python for. I just thought I would throw that in there, because sometimes we might be working with all these numbers and you're saying to yourself, but Fru, explain to me why this makes sense, right? This is just basic, this is rudimentary stuff. Guys, these are building blocks to really amazing thing you can be doing with numbers within Python. So this is fundamental, all right? Let me make sure that I remove that so it doesn't crash that. Let's actually keep that very small. All right, so what else can we do? There's a lot more we can do. We can print, take two numbers, and then we can say max, or let's say you had multiple numbers, right? You can have 5 comma 1 2 comma All right, so I can have a list of numbers as such. Okay, it's a long list of numbers as such, and I can tell Python which one of these numbers is the maximum. If I have a list of numbers the way I've written them here, and I want to figure out which one of them is the maximum, I can use the max function within Python, and it will tell me the maximum number. So this is raise power. This is maximum. This is absolute. Let me make sure that we name those. All right. So now manually I can really look at this and try to figure out. It's I'm not sure. It's just a lot of numbers. But if I just run my code, guess what? It tells me 37. All right. Let me keep this simple. It tells me 37. All right. So imagine you had a list of 10,000 numbers and you wanted to figure out which of them was the maximum. You can go ahead and try to manually figure it out and scan and look at it by yourself, or you can just write the Python code, put in all those numbers into Python, and it's gonna figure that out for you. So that's how Python can be very powerful. All right, and we can do maximum. We can also go ahead and do minimum, right? Because we don't always have to do maximum. We sometimes want to say show me the minimum number. Here we just simply change our function to mean, and we can now get a minimum of all the numbers, and in this case it was the minimum is 2. All right, and you can use this to write a program that takes your students averages, and you want to find the maximum one, the student with the highest average or the highest grade point. You take a student's GPAs, and you want to find the minimum, the student with the lowest grade points. That way you can rank them and that way you can congratulate the one with the highest grade point, and then maybe provide more tutoring for the one with very low grade points. All right, so that's the power of Python. So Python can allow us to do that. Now let's continue going down the list. We can print say we're working with numbers, doubles, and we can have 5.57. all right, so let's say we have a number 5.57. that's we've seen that this is a float according to Python. But what if we want to round this number, right, to the nearest integer, to the nearest whole number? In math, it's the nearest whole number. So we can say print round, and we can round this to the nearest whole number. Now, guess what? It rounds this to 6. But what if I did 4? That, right? Because it's less than the half of that, it's going to round it down. So if it's above the lowest, above the half point, it rounds up. If it's below, it rounds down. So now it's rounding down to 5. All right. Let's see. Some of you guys will say, what if I put 50 in there? It rounds it up to 6, right? So it takes from 50 and above, right? So, but if I went to 49, then it's going to round it down. All right. And I encourage you to take any numbers. It doesn't have to be one decimal place. You can go as many decimal places as you can. This is still going to round down. All right. And be able to play with it and see how you can round numbers. But let's look at another concept here, which is called so let's say round up and down. All right, let's look at another concept here called, let's say we wanted to specifically round this number down. I don't care whatever whether it's above or below that half point. I want to round it down. So you can use the concept of a floor. All right, so you can use the concept of a floor, and then we put in that number. So let's write round down. So floor, think about, you have a house, you have a ceiling, you have a floor. So if I'm somewhere here and I say take this to the floor, boop, I'm taking it down, right? If I'm here and I say take this to the ceiling, I'm rounding up, right? So floor, down, ceiling, up. Very basic. All right, let me make this that way. So it's gonna round that down. Oh, voila. Okay, so now this is gonna give us a very interesting concept here. When I said floor, it complains. It says name floor is not defined, and this will now come into the concepts of libraries. or packages within Python. If you're not familiar with that, just hang on. I think it may be in the module 8 or around module 8 or module 7. That's covered. So check it somewhere there if you find that. Otherwise, let me know. But basically, some of the functions are pre-built into Python, but some of them you have to manually import them. So you just take it for now. If you have this error, just hover over this, right? And then click on import math.flow, all right? And what is done is, if I go back up here, let me actually copy this to the top. So what is done is it's added this new line for me within my code. So it said from math import flow. So it's gonna import the flow package. That way I can use that function to say flow, because if I don't import this, it will not work. So just for now, just go up to the very first line of your code and type from math import flow. All right, and I'll talk a little bit about this because we're gonna see another issue that will come up here in a second. So now if I run this, this should round this down to 5. All right, even if I had this as 5.999, it's still gonna round to the floor of 5. All right, it's still rounding that to 5. Now let's go ahead and change this. There's another function called ceiling. Let's do 5.01. all right, and I'm gonna say seal. All right, actually I didn't spell that correctly. All right, so you see it still has some issues. If it asks me here, it will say, well, I need to still go import ceiling from that math library, and I can click on that. And if I go up, where is that? For some reason it doesn't put it on my first line of code, so let's just find where that is. All right, so actually it's put it there. All right, it said floor, and now it said comma ceiling. All right, so for me to be able to use this ceiling function, is imported that. So assuming that I needed another function, let's say middle, right? If a function existed called middle, will I have to come in here and type that? All right, or Fibonacci's or fabs and things like that. That could really be annoying to do. So another way that you can solve that problem is just to say math.import star, and it's basically going to bring anything within this library, the math library, for us to use. That way you don't have to be physically telling it bring ceiling, bring floor, bring absolutes, bring Fibonacci, and all of those things. So it just makes life a lot easier. So if you type in from math import star, is going to bring in everything. And if this doesn't make sense to you, I'm going to be covering this a lot more in some future videos, so just stay tuned for that. All right, so now if I run this, so since I'm doing ceiling, remember ceiling is what? Up, right? Even though I'm saying 5.01, if I just did round would round it to this down, right? Round would just round this to 5. But because I'm saying ceiling, I'm saying you have to round this to the nearest biggest integer, not to the nearest integer, to the nearest biggest integer. Then ceiling by force, think about ceiling up, rounds it up, right? If I did floor, it would take it down. All right, so that's some of the power of the math library. We can go ahead and do something like let's say we have a number 25, all right, and we wanted to figure out square root. All right, you can use the square root function. All right, if I gave you a number and say find me the square root of this number, all right, you can just simply use the square root function, and we know the square root of 25 is 5. All right, so it gives us 5 right here. All right, so these are some functions that are available within Python for us, some mathematical functions. There's a lot of functions that are available. This is just like the tip of the iceberg. Whatever you might be thinking about doing in Python, all right, mathematical base, guys, there's probably a function somewhere that you can take advantage of to be able to work in Python. So it's just a matter of searching around and you can find the function to use. Let's just say I go crazy with this. This might take a while. Let's say that. All right, imagine somebody asks you to find the square root of this. How would you even start to figure that out? All right, but in Python, now I have a value here. All right, it's kind of a decimal floating point value, but you still get a value. You still get a value. If I square this number, I'm gonna get this. All right, so that's it for this particular concept within this lecture. So what I'm going to do is I'm going to end that. Zoom in here. We've seen a lot of mathematical functions. I'm going to end that, and then we're going to go now into our next concept, and this will be concept 1.2.5. and in 1.2.5 we are going to see converting numbers from one type to another. All right, so converting numbers from one type to another. Now, in our previous lecture, in the previous concept that we saw before, we saw how to check number types here, right? Where you can say print type and then a number, and it will tell you what type it is. Is it a decimal, which is a float? Is it an integer? Is it a complex number? All right. Now, what if I have a decimal and I want to convert that into an integer? Or what if I have an integer and I want to convert that to a decimal, or vice versa? All right. How do you do that in Python? And basically, this particular concept in this lecture will be, explaining that for us. So let's assume we have a number x equals 1. All right. What is this number? Based on what we saw, this is what? An integer, right? So very, very, very basic. All right. Now, let's say I wanted to take this number and make it a decimal. Let me actually print x. So we can see very well that x is an integer. And it's an integer because it doesn't have any trailing decimals. All right. So print x, right? Let's say x equals 3. Print that. So it prints 3. Now, what if I wanted to make x into a decimal or into a float, right? So how can I do that? I can say print, and all I need to do is just type float, right? X. All right. So now you remember this was printed. Let me actually do it 2 ways. So what we're going to do is going to print x. So what we've done here is we've printed x, and then we're going to print x as float. All right. And you see the difference between the two. All right. X as an integer. Now x as a float has 0.0 behind it. So we've simply taken an integer, which is one type, and we've converted it to another type, which is a float within Python. All right. And you might be asking, there might be reasons to do this. If you think about GPA, maybe they want to give you your GPA for school as just an integer. They want to give it as 3.1 or 3.5 instead of just 3, right? So an integer might not work in that case. You need to convert whatever you get into a decimal or into a float so you can work with it. And so those might be reasons why you might want to have to take data from one type and convert to another. Of course, there are many more reasons. But if you ever come across a scenario, this is how we can convert from one to another. All right. Or we can say, let's say y equals 2.8. All right. And we know what is this? This is a float. All right. What if we wanted to print this, copy this. All right. Let's print y here. All right. And then let's actually, instead of taking integer to float, we're going to take this float that we have, that's y, and we'll convert it to integer. All right. So to do that, we just say int. All right. And then we put in y in there. All right. So float takes whatever number, converts it to a float function using that function. Int, if I give it a decimal, it's going to give me an int. If I give it an int, it's going to give me an int. So let's actually run this. So you can see here I had 3, it printed 3.0. Then next one I had 2.8, but it gave me 8. All right. So an int, the int function here is able to take an integer, or is able to take a number, a float in one type and convert it to another type. So very, 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 very powerful. And then you can go ahead and check the type, right? You can go ahead and say print type. You remember how we were able to check the type? Print type of x, print type, actually this should be my X, and this will be my Y. All right, so it's gonna print us the types at the very beginning, at the end. So X is int, Y is now float. So let's go back here. All right, X is int, Y is float. The reason why it hasn't changed is because I did not actually change the specific types. So instead of doing this here, let's actually change the specific value. So type, right? All right, so if I do type and I do int here and I do float, so you have to change the specific X. So even though we change the printing, we did not actually change the value. So if I actually change it there, so even though this is an int, I'm saying that make this into a float. Even though this is a float, I'm saying make this type into an int. And so here we'll see the results would reverse. So this will be float and this will be int. So let's run it. All right, so this is float and that's int because we've actually changed the types of the value. All right, so that's how we can go ahead and we can change types of values. All right, guys, there's a lot more that we can do. What I would really want you to do is to play around with this. Take any number you want, see that you can change the types, print it on the screen, verify that you have the correct types. That would be a very, very good exercise to do so you can start getting familiar with this. All right, if somebody gives you a number and you want to make sure that it's always a decimal or it's always a float, just make sure that you change it into a float. And the way you do that is to leverage float. All right, now next piece here. All right, so this will take us into concept number 1.1.2.6, and in this we're going to look at printing random numbers. So the whole idea behind this concept within this lecture is to see how we can work with random numbers and to be able to print them to the screen. And you might be asking, but Fru, why is random numbers relevant? Or why should I want to print a random number on the screen? And the reason is simple. There are some times where maybe you're working on building a game and you need to generate some random numbers for the users. Right? Think about like a dice, right? You want to throw a die and randomly generate a number and you want your program to do that. And that's a number. So you might want to leverage a random number function within Python to help you generate that so that it's random enough. All right, so that's what we're going to be covering here on the screen. So for that, we're going to set a quick function right here, x, a variable x equals to random. All right, actually, let's make it a range. So we do ran range. All right, and what it does is it gives us to say we can generate from 1 to 6, right? If you're working with say you're generating a dice, you want to generate random numbers between 1 to 6, and then we can go ahead and print x. So if I run this, all right, so you see it printed 3. Now if you do this run range and you're missing something, what you want to do is make sure that you've imported this particular library, right? From random import star. So this is what you need to be able to work with this particular library for math, right? And now it's generated a random number for me between 1 and 6. So each time I run this, right, it's gonna generate a new random number, right? You can say between 1 and put any high number. All right, so it's gonna always generate a random number for you. Now you can take this random number and do something with it, right? If I'm putting it between 1 and 10, then I can take it and use it, say, for my other application. So if just to give you an idea of how you can generate numbers to use to build your applications or to build games, you can always generate random numbers. All right, guys, so this brings us to the end of the concepts we have covered in this lecture. It's been a lot. We've talked a lot about numbers. I hope this gives you a lot of ideas about working with numbers within Python. All right, there's a lot that you can do. Whether you're a student, you just want to be able to make it easy for your math class, you can take advantage of a lot of the math capabilities and numbers capabilities within Python to really get ahead, right? You might be a scientist, right, that just needs to do more complex advanced numbers. This gives you the ability and the capability to do that. So these are very, very powerful concepts. And to recap, what we've seen here today is If I go back to my script here, we've seen basic numbers. Let me increase this a little bit now. We've seen basic numbers. We've seen how to work with number types and to be able to change them, right? Integers, floats, complex, those are the main types, and how you can change from one type to another type. We've seen how to do arithmetic operations within Python using mathematical functions, using mathematical operators like plus, addition, subtraction, division, modulus, and more. All right, we've seen bookmarks, orders of operation. Just because you write something doesn't mean that it's going to give you the correct answer. You kind of have to tell the Python program to know how to operate it. So use brackets to tell it the order of operation so it's operating correctly. We've also seen more functions. So in addition to plus, addition, division, subtraction, multiplication, there's more that we can do, right? We can do absolute values. We can do square roots. There's just a lot of things that we can do. And those are all available within functions in Python. And then we also saw how to convert numbers from one type to another, which I mentioned a little bit earlier. And then at the very end, we were able to print random numbers. So you might be in a situation where you want to print random numbers for whatever reason, right? Maybe to build a game, to build an app. You can take advantage of the random number capabilities within Python to go ahead and to be able to generate and print random numbers to the screen. All right, and as part of that, we were able to import some external libraries to facilitate that. So these are all the concepts. This is a lot of concepts, but numbers are everywhere around us. The stock market is all numbers. A lot of scientists, their discoveries are around numbers. The climate change is increasing by so and so degree, right? That's numbers, right? The temperature outside today is so and so temperature, so and so value. That's a number. So a lot of things around us boils down to numbers. So it's very important that we understand and have a good mastery of working with numbers within Python. All right, so that has been today's lecture. Thank you for sticking with me through this. I know it's a lot of content. For next lecture that we're going to be covering, we're going to come in, since we've seen numbers, we're going to be looking at strings. So we're going to be working with strings. So strings is a counterpart to numbers. Both are very, very important concepts to be familiar with. So strings is what's coming up. Now, for numbers, if you want to follow along, like I mentioned, all this code is available in my GitHub, so you can see all the exercises that we went through today. If you want to download this into your Python environment, PyCharm, that way you can follow along, you can run them to see exactly what they look like and get familiar with it. Guys, that would always be highly recommended. And as always, if you have any questions as you're following along with this series of lectures, guys, jump into the comment section below. Leave your comments, leave your questions. I will be more than happy to ask. The whole goal for doing this is really to educate, all right? And practice makes perfect. Some of this might seem foreign to you, but trust me, the more you are sitting in front of your Python, PyCharm environment, or whatever IDE you're using, and you're just playing around, the more it's really will click into the head, and sooner or later you find yourself waking up in the morning and being able to write any Python program that you want to write. All right, thanks for joining us today. This has been Fru. I will see you in our next